So if we look at this question, we're asked to convert 45.3 cubic meters to liters, and we're also told that 1 milliliter is equal to 1 cubic centimeter. So before we go any further, I just want to go over the relationship between length and volume units. We see that these are volume units, and one of them is expressed as a length cubed. And this is derived from the fact that for regular solids, one can calculate the volume. And so let's look at this cube here, and let's assume that the length of one side of the cube is 2 centimeters. Well, the volume of a cube can be calculated by multiplying its length by its width by its height, and since it's a cube, all of those values are the same. So it's 2 centimeters times 2 centimeters times 2 centimeters, which is 8 in terms of the numerical value, and then the units also get multiplied by one another, and we end up with cubic centimeters. So because regular solids have a volume that can be calculated, and when that volume is calculated, some length unit always ends up being cubed, we can look at volume as a length cubed. Now, in terms of deriving the conversion factor, what we're going to do is we're going to use the length conversion factor as our starting point. So I know that 1 centimeter is equal to 1 times 10 to the minus 2 meter. You could also write 100 centimeters is equal to 1 meter if that works better for you. And then to get this length conversion factor to a volume conversion factor, what I do is I cube both sides, because length cubed is a volume. And as long as I'm doing the same mathematical operation to both sides of the equation, I am permitted to do that. So 1 centimeter cubed, 1 times 1 times 1 is 1, and centimeter cubed would be centimeter cubed. And then on this side, 1 times 10 to the minus 2, if I put that into my calculator and cube it, I'll get 1 times 10 to the minus 6. And again, my unit, if that's cubed, then it ends up being cubed in the final result. So here I have highlighted my volume conversion factor, which I derive from my length conversion factor. Now I'm going to use the typical way that I've taught to solve this dimensional analysis problem. I'm going to write down my given, which is 45.3 meter cubed. I'm going to write down the unit that I want, which is liter. And then I'm going to do a 2-unit check. So here, centimeter cubed is equal to 1 times 10 to the minus 6 meter cubed. I have centimeter cubed and meter cubed. So I have 2 units of meter cubed. And then I'm also told in my original, I'll bring it back down, that a milliliter is equal to a centimeter cubed. So I'm going to use that because that gets me from my length cubed to a liter or a prefixed liter unit. So now I have 2 of my centimeters cubed. And then, since this is a prefixed unit, I can get to my base unit. 1 milliliter is 1 times 10 to the minus 3 liter, because milli means 10 to the minus 3. So if I do my double unit check, I have 2 of every unit, 2 milliliters, 2 centimeters cubed, 2 meters cubed, and 2 liters. Now I know I'm ready to do my railroad math. So here I have, so here's the work that I did. I started with my given, which is 45.3 meters cubed. I have meters cubed in the denominator, so I know that I need meter cubed in the numerator. Looking back at my conversion factors, I have one conversion factor that has meter cubed in it. And so this is where I get that conversion factor from, the ones that I've already written. So let's go back to the work. After meter cubed gets canceled out, I have centimeter cubed in the numerator, so I know that centimeter cubed goes in the denominator here. And my conversion factor was the one that was given, 1 milliliter is equal to 1 centimeter cubed. And then my last conversion factor is the relationship between milliliter and liter. Since I have milliliter in my numerator here, I want milliliter in my denominator. And the other half of that conversion factor is 1 times 10 to the minus 3. All my units cancel out except for liters, and there are lots of different ways you can actually do this math. What seems to be students' favorite way to handle railroad math is to multiply all the values in the numerator, multiply all the values in the denominator, and then at the end divide the denominator into the numerator. So if you do that, your final answer will be 4.53 times 10 to the 4th liters. And I began with 3 significant figures, so my final answer should have 3 significant figures. Even though these conversion factors only have 1 significant figure, they are considered to be infinite in precision or an exact number, and so therefore they're not going to affect the number of sig figs we have.